My name is Hercho Perena, and today I'm going to present to you the Euler's identity. Now, this man right here is Leonard Euler. He made this Euler's identity formula around 1730s. He made some contributions to the world of math and physics, and also to the number theory to fluid mechanics. In order to do this formula, Roger Cotes, first in 1714, he made a formula that explained the relationship between logarithms, trigonometrical functions, and imaginary numbers. Then, 20 years later, here Leonard, he did the same formula, but instead of logarithms, he expressed it with exponential functions. Now I'm going to explain to you what the formula is, and just for starting, this equation right here is called the most beautiful mathematical formula because people say that it's elegant, and as you can see, it gathers 5 of the most important mathematical constants, which is e, I, pi, 1, and 0. And also, when you apply it, it has some cool mathematical and physical interpretations. Now we're going to analyze it. Starting, it has AE, which is an exponential function, and this is like very special because E, it's its own derivative, e to the x. If we take the derivative of e to the x, it's equal to e to the x also. And we have E elevated to the I. It stands for imaginary number, and then the pi. This means, well, this allows this equation to be elevated to any exponential number, and allows it to be negative because it's an imaginary number. It, in terms of the mathematical logic, it doesn't exist because each negative number elevated to any exponential number, it results to a positive number. So this allows it to make it negative. Since the traduction, the equal to I, it's square root of -1, for example. And then we have pi, which is the diameter of the amount of times that the diameter can fit in the circumference of a circle, which is 3.1415, etc. It's a number that it's like infinite, but it stands between the 3 and the 4. And last but not least, we have the 1 and the 0, and these ones stands for the fact that every number, which is real or imaginary, can be resulting, or the derivates from these two numbers. Every number that you can imagine can be done by joining these two numbers, the 1 and the 0, if in any order, with any operation you want. And for example, you can add 1 plus 1, or 1 minus 1, 0 minus 1, 1 over 0, 0 over 1, 1 over 1, etc., etc. And this is all for the Euler's identity.